Hello everyone, I'm Ahmet Esen, a PhD student from Heriot-Watt University. My PhD is on experimental and numerical analysis of high-speed rail infrastructure, and in this presentation I'll be talking about analysis of a new ballastless track for high-speed railways. A new type of slab track was developed by Alstom and other French companies called new ballastless track or NBT. In my research, I focus on analysis of this track using finite element method. As the first stage of my research, a 3-sleeper section of a generic slab track was tested, both statically and cyclically, and we applied real axle load, and we obtained elastic and plastic deformations. After this, I moved on to my second stage, which is calibration. I simulated the same dimensions, again, 3-sleeper section of the track, and same soil parameters and track parameters in abacus environment. And then I calibrated basically the soil parameters, which are elasticity modulus, density, and Poisson's ratio. After calibrating the model, I move on to a full 3D model, which is an enlarged model of this calibrated model. It is this calibration was 3D model, 3-sleeper sections, and full 3D model is like 100 sleeper sections. It is 65-meter long, 50-meter deep, and 30-meter wide. And various train loads traveling at high speeds were applied. Here, this is the train load at the bottom of the slide, you can see. And I applied first vehicle traveling at 360 km per hour. In this animation, you can see. So the green waves show the seismic waves traveling in the soil domain here. And in these graphs, we can also see the wave propagation under this vehicle 1 traveling at high speeds. Here in this isosurface 2. So non-reflecting conditions were used to absorb the waves hitting the boundaries of the soil domain. Here I can show with this. So these sides, and for example this side, it's infinite elements. This is for non-reflecting boundary conditions. And in this model, I have roughly 100,000 elements, and the time increment is very low to catch the waves, the seismic waves. And to reduce the computational cost, I replaced this finite infinite element with viscous elements, and I used parallel computation to increase the computational speed. And in the next stage, I will be applying 6 vehicles, as you can see here, 6 vehicles traveling at different speeds on this track. Thank you so much for your time.